to do is share my screen once I get back to the right class. Here we go. All right, and if someone could send in the chat and let me know that you can hear me, that would be fantastic. All right, perfect. So if you look down under Thursday, whoops, you might need to refresh your pages. There is this atomic structure review quiz. And so this is actually the same quiz that you took last week, except this time it's in a Canvas quiz form instead of a Google form. So why don't you take a moment to refresh your Canvas page, and then we're going to open up this review quiz, but we're not going to start it yet. We're going to review first. So we've got these atomic structure notes. Let's see, to make sure. I don't know if you can still see my screen when I do that, so we'll just leave it like this. So atomic structure, if you want to take out like a piece of paper and pencil to take notes, or if you just want to review for a moment, that's fine. But let's see, let me know when you're ready to go. So here's the atomic structure, and the atom is the smallest unit of matter. Different atoms have different properties, so like bond and charge. And smaller particles, subatomic particles, have consistent properties. And this presentation is linked in the quiz if you want to review again later. We're just going to walk through this right now. We're going to take the quiz, and then we're going to move on to our next activity. And then I'm going to use that quiz to figure out what we need to review before the test next Tuesday. And then we have subatomic particles, and they are the 3 parts to the atom. Protons have a charge of +1. Their mass is 1 AMU. They are in the nucleus, and they change the name of the atom. We can also call them the atomic number. So protons and atomic number are always the same thing. Then we have neutrons who have a charge of 0. They weigh about 1 AMU, same as the proton. These are also located in the nucleus. And the neutrons are what affect stability or radioactivity. So whether an atom will be stable, so if it's not, in our examples, we always saw like the nucleus would shake if it wasn't stable, or radioactivity, so whether it's going to emit radioactivity. And so we can talk about that later. But we're looking at neutrons are neutral in the nucleus. And they weigh about 1 AMU. And then these affect the stability or radioactivity. And then we have electrons who have a charge of -1. And these really don't have any mass at all. They only weigh about 0 AMU. These are located in clouds or orbits around the nucleus, so they're outside the nucleus. And electrons are what allow chemistry to happen, so these affect bonding or reactivity between atoms. All right, then we have elements. So when an atom has a neutral charge, the negative charges, which are electrons, must equal the positive charges, protons. So you'll have the same number of negative charges as you do positive charges. When an atom has a positive charge, the positive charges are more than the negative charges. So you have more protons than you have electrons. And when an atom has a negative charge, the negative charges or electrons are more than the positive charges. So you'll have more electrons than protons when an atom has a negative charge. All right, then when we're looking at our periodic table of elements, there's a lot of information. So the top number so the whole number that you see, it's always going to be a whole number, is the atomic number. The big letter is the chemical symbol. Then it has the element's name, and then the bottom number is the mass number or atomic mass, and this is our number of protons plus neutrons. So remember, we're going to calculate atomic mass or mass number by adding protons and neutrons. Actually, back up in electrons, I'm going to write, we'll do protons minus electrons equals charge. So this means that in order to find the charge of our atom, we're going to do protons minus electrons. And then to determine the atomic mass, we're going to do protons plus neutrons equals mass number. Let's do, try and make this fit. There you go. So protons plus neutrons equals mass number. So that's how we're going to be calculating these things. And then we have ions, and ions are any atom that has a charge other than 0. And there's two types. You have cations, which are positive, and anions, like negative ions. And I like to remember these by cation. Cats have paws, so cation is positive. And anion sounds like onion, and onions make you cry, so it's negative. So there's a little bit of review. So now what you're going to do is you're going to take the atomic structure review quiz. And then once you're finished, send a message in the chat saying you're done so I can keep an idea of how many people are ready to move on. So take some time to do this quiz. I'll preview it right here so you can see what's on it. But it should be the same as what you did last week. So we're going to see if you have anything that we need to go over again or if we're feeling pretty good about our work. So I'm going to stop sharing my screen and go back to the screen, the Zoom. So work on that quiz, and then remember, let me know when you're done so that we can move on to our next activity. We'll say at about 8:15, we'll check in again, and if people still need more time, then we'll give you more time. All right, looks like people are starting to finish up, so we'll say 8:10, and if we still need more time, then let me know, but we'll plan on being finished around 8:10. All right, does anyone need more time? All right, since no one is saying anything, I'm going to take that as a no, so we can continue. Let's see, do we want to... Let's just go over the quiz right now. We'll keep reviewing, and then we'll move on to our next activity. So what I'm going to do is I have the preview open. So we're going to work through this together. So that means I'm going to need people to send messages in the chat. So let's see if I can get this to work. So I'm going to split my screen. I have a better idea. We'll do it this way. There we go. So for this question 1, mass number is determined by, and if you know the answer, go ahead and send it in the chat. We'll just do a few of these. We won't do the whole quiz. Does anybody know what mass number is determined by? There it is. Yes, so your neutrons and protons. So we'll select this one. Let's do one of these. So if a beryllium atom has 4 protons, 5 neutrons, and 2 electrons, what would be its mass number? Beautiful. Let's do... Choose the correct number of electrons for the following oxygen atom. Atomic number 8, mass number 10, and charge of -2. Beautiful. Wonderful. So my trick is you're going to do the opposite of the sign in front of the charge to the atomic number. So if the charge is -2, we're going to do +2 to 8, and we get 10. Good job. All right, and let's do this one. We've got choose the correct number of neutrons for the following boron atom. Atomic number 5, mass number 10, and charge is +2. Yes, Sawyer. Yes, Brady. Yes, Sebastian. It's 5. We're going to do the mass number minus the atomic number. So 10 minus 5 is 5. And then let's do... What must be true about a neutrally charged atom? So you can either say option 1, 2, 3, or 4. So you don't have to type the whole thing. All right, there I'm getting some mixed answers. We've got 4 and 3. 3. All right, so this one looks like it's tripping a couple people up. We've got there's a good, all right. So we've got 3 option 3s, which is correct. It's equal amounts of protons and electrons. So when an atom is neutral, that means it has the same number of positive charges as it has negative charges. Neutrons don't have any charge. So if we had equal amounts of protons and neutrons, this wouldn't necessarily tell us what the charge is. It would tell us that we have a positive charge. But in order to have a neutrally charged atom, we're going to have equal amounts of protons and electrons. So that's option 3. So good work on this. We are going to switch gears and start on our next activity, which is our AACT isotope simulation lab. So go ahead and open this up. If you want, you can just open the worksheet, and then I'll have the lab open on my computer so that we can work through it together. So I'm going to do this. And we are going to open this link. All right, so this first part is tutorial. So you will eventually need to open this on your own so you can do the practice. But for this first part, we'll leave this on my screen and you can fill in the blanks on your screen. So we'll try and get this to be as big as we can. So looking at these 2 carbon atoms, or isotopes of carbon, we're going to figure out what the similarities and differences are between the 2 carbon atoms here. So we're going to start, we'll do similarities and differences. So similarities. Why don't you start filling this out on your own and then we'll talk about it. So I'll give you we'll work on this for a minute and then we'll discuss and then we'll start on our next question. All right, can someone send one similarity that they see? Good. So we have the same number of protons. Ashley says the amount of electrons. Perfect. So we have the same number of electrons. Anybody notice any differences? Neutrons are different. Good. So we have different number of neutrons. Does anyone notice anything else? Yes, Ashley, abundance. Their abundances are different. So we have different abundances. All right. How about anything else? Anybody else notice anything different? There's one more thing that I can see. They are both carbon, but what about carbon? So different amount of neutrons, yes. So what does that also tell us? They have different what? I'll give you a clue. It's in the names of the carbon. If you remember from Monday, when we talked about naming isotopes, what's included in the name of the isotopes up here? Is it the atomic number? Is it the charge? Is it the mass number? So I see a difference up there, and is that in the atomic number, charge, or mass number? What do you guys think? Beautiful. So Ashley, since we have the same number of protons and electrons, that means we have the same charge. But looking up at our names of the isotopes, this carbon has a mass number of 12, while this carbon has a mass number of 13. So the mass numbers are also different. So then we're going to calculate the mass number based on the particles in each atom. So what we need to do is we need to figure out what the mass number of this one is based on the subatomic particles and what the mass number of this one is based on the subatomic particles. So we'll do carbon 12, and then we'll show our mass, and we'll do carbon 13, and then we'll show our math here. Once you've figured it out, send me the subatomic particles you used and the equation you used to find the mass number. I'll leave this up for a little bit longer, and then I'll go check the chat again. All right, how are we calculating mass number? What two subatomic particles are we using? Good, Brady. Protons and neutrons. So there's another way you can look at this. Most of our mass is going to be concentrated in the nucleus. And in the nucleus, we only see protons and neutrons. So that means protons and neutrons are the only ones contributing to the mass of the atom. So for carbon 12, if we do protons and neutrons, we have 6 plus 6, which is 12. And that matches, so that's good. And then for carbon 13, we have 6 plus 7, which equals 13, and that matches, so that we know we did that correctly. So carbon 12 is 6 protons plus 6 neutrons, which equals 12. And then we'll put our units 12 AMU. And for carbon 13, we have 6 protons plus 7 neutrons equals 13 AMU. All right, so now carbon 12 and carbon 13 are isotopes of each other. In your own words, what do you think is the meaning of isotope? And use the carbon atoms shown on the screen as an example in your explanation. So what I'm going to have you do is you're going to fill this out and then copy and paste what you put here into the chat, and then we'll have a discussion about it. So take some time to determine what you think an isotope is, and then we'll decide as a class what we're going to define isotope as. So once you're ready, I'm going to ask at least 3 people to share their answers. If more people want to share, that would be even better. But at least 3 people are going to share before we move on. All right, 1 second. I'm sorry, I'm getting a phone call from Beaver Dam, so I should probably answer this. All right, sorry about that. I interviewed for a long-term sub position at Beaver Dam Middle School, and they were just calling to let me know that I got the job. So I get to be in Beaver Dam for the next semester. Woohoo! All right. So Sebastian, the meaning of isotope is that there are 2 types of the atom that are the same but differing masses. For example, carbon-12 has an average mass number of 12, while carbon-13 has an average mass of 13. So that's good, but we're missing one important piece of information. So who wants to add on to Sebastian's definition? Because this is a fantastic start. They do have different masses, but we're going to talk about why they have different masses. What's causing the mass to change? So I'm looking for one word in particular, one subatomic particle. Who feels confident in their answer? I know at least one more person can. All right, looks like we're not having any volunteers. So what I'm going to do is I'm going to give you that word, and then we'll try and get you to discuss. I know it's early and we're sleepy, but we're going to participate in class. So the word I'm looking for is neutrons. So how can we include neutrons in Sebastian's answer? to make it a little bit more specific, because we could have two atoms with different masses, but they could be two different types of atoms. So what are we going to change about neutrons to make our mass of the same atom different? All of a sudden, everyone got shy. There it is, Sebastian. He changed his own answer. So that's the amount of neutrons. So back in our answer over here, I'm actually just going to copy Sebastian's answer, and then we are going to edit it. So 2 types, and then we're going to add here, I'm going to make this bigger. 2 types of the same atom. Oh, no, you have it there, that are the same but different. And then here we'll say number of neutrons, which changes the mass number. So isotopes are the same type of atom with different numbers of neutrons. And that in turn causes the mass number to change. So keep that in mind. And then based on the abundance values for each isotope, would you expect the average atomic mass of carbon on the periodic table to be closer to 12 or 13? And why? So looking at our percent abundances, would the mass on the periodic table be closer to 12 or closer to 13? So in the chat, since it's only a little bit of writing, I hope we'll have a couple more people say what they think. So what do you think, 12 or 13? Is it going to be closer to 12 or is it going to be closer to 13? 12, because the percentage of abundance is higher. Okay. Does anyone disagree with Abigail, or does anyone agree with Abby? All right. Looks like we are very, very shy all of a sudden and don't feel like talking. So we'll just go with Abigail's answer. And yes, carbon 12, because the percentage of abundance is higher. So this means that most of the atomic mass is going to come from carbon 12. So the mass on the periodic table will be closer to carbon 12. So actually, we're just going to copy her answer here and paste into our worksheet. All right, in the simulation, scroll down to the header, calculate average atomic mass. Study the average atomic mass calculation for carbon. Where do the values 0.9893 and 0.0107 come from? So here we're going to look at this part. Might need to make this bigger here. There we go. So looking at this, do we see these numbers anywhere else? So I want you to look around and see if you see the same pattern of numbers somewhere else on the page. Let's see if anyone wants to volunteer. Ellie, yes, it is the percentage of abundance. So this means that we take these percentages here, and that's their abundance, and we convert it back to a decimal. So right now, a percentage is actually a fraction. So it looks like this. So if we have 98.93%, it actually looks like this. in the chat, you can see I sent 98.93 divided by 100. That's what a percentage is. If you break down the word percent, it means per 100, because cent that's Latin roots for 100. So it's 98.93 per 100. So we're going to divide by 100, and that's where the 0.9893 comes from, and the 0.0107 comes from. So they are the percent abundance. All right, so now you're going to need to open up your own AACT simulation, and the link again is just up here at the top. And you're going to go through practice, and so you're going to need to build at least 3 different mystery elements using the simulation. For each mystery element will have a different number of isotopes as indicated in the table below. For the name, masses, and abundances of the isotopes, you will choose those from the options on the screen and record your selections in the table below. Based on your selections, you will calculate the average atomic mass for your mystery element and then use the Calculate button on the screen to check your answer. An example is completed on the table for your reference. So you're going to be doing something like this. So you're going to need to make 3 new isotopes. So this one has 2 isotopes, 3 isotopes, and 4 isotopes. And you're going to fill in the rest of this table. And the practice tab is right here. So once you're ready, go ahead and start working on this. I'm going to stop sharing my screen. Actually, once you finish this, I'm going to share my screen again. You have an isotope mini quiz to finish. So once you've turned in the isotope simulation lab, start working on the mini quiz. And if you finish early, then go back through your assignments. Make sure you're not missing anything. We have a test next Tuesday, so you might want to start studying, looking back at your notes. Or if you have any questions or you're confused about something, this is a great time to ask for help. So you're going to work on the mini quiz. And remember, you're going to submit a screenshot of your final score to Canvas. Don't forget to do that, otherwise it'll get marked missing and we won't know you turned something in. So make sure you do that. So go ahead and start working, and then just send me a message in the chat box if you have any questions. But I will be here for as long as anyone needs help.